So at this point, we're going to move on to the second job of lymphatic tissue, which is to clean the lymph as it passes through the lymphatic system. So the first thing we have to cover is the concept of lymphatic tissue itself. Just so you know, we're going to be coming across some very similar types of material that I want you to be able to recognize. These are called lymphoid follicles, and here we're showing a lymph node. But inside of a lymph node, we have something that looks a lot like lymphoid follicles. So lymphoid follicles are basically pockets of the tissue. Anytime you see anything that looks somewhat like this, these are probably lymphoid follicles. Now, these are called Peyer's patches that are found in the we'll talk about those down the line. These are the tonsils. Again, you'll see these lymphoid follicles that are part of the tonsils. So whenever you look at lymphatic structures, it's pretty much always going to have something that looks somewhat like that, and that is representing lymphatic tissue. So lymphatic tissue is made of reticular connective tissue. Here we go. The reticular connective tissue is a replication site for the lymphocytes. It allows for lymphocytes and other white blood cells to rest in this region and then leave to patrol the body, moving between the blood capillaries and the lymphatic tissues. And this circulation ensures a fast response to infection. So you start to see the tie-in here. The lymphatic system is not just a system of drainage for interstitial fluid. It also ensures that as that fluid is moving through, it is coming into contact with a number of different cells that are going to help fight off any infections that might be part of that lymph. So in this picture, you can see there are, this is called a reticular fiber stroma. The reticular fiber stroma is actually produced by these weird cells called reticular cells. And so the stroma is a network that supports other cells. So most of what you're seeing in here that kind of sticks out are lymphocytes and macrophages. Dendritic cells are another one. And these help to, for example, phagocytize foreign substances to activate the T cells, or they could be lymphocytes that are ready to attack foreign substances such as specific bacteria, viruses, and toxins. So this is kind of a big picture of how the immune system actually works. Much of the work of the immune system is done inside of these lymphatic tissues. So when we look at an actual lymph node, it's quite small. It's usually less than 1 inch, unless you're fighting off infection. Then it could actually get to be larger than that. The lymph nodes are most prevalent in the inguinal, axillary, and cervical regions. It's a compact little bean filled with lymphatic tissue and those cells. So keep in mind that even though we're looking at this structure now, keep in mind that it's filled with this type of tissue. One of the things that we'll notice here are germinal centers. So here's lymphoid follicle, basically. Inside of the lymphoid follicle, you'll find a really dense region of B lymphocytes that is called a germinal center. Okay, so the lymph nodes are the main lymphoid organs. They cluster around your lymphatic vessels. They are embedded in connective tissue. Their job is to filter lymph as it is passed toward the blood. Generally speaking, you're going to have a lot of phagocytes present to remove and destroy microbes and debris. And the other side of it is not only are they removing them, but if they come across something particularly nasty, they will activate the more specific, more powerful side of the immune system by interacting with the lymphocytes that are right there. The T cells and the B cells are the most powerful soldiers when you're fighting off a really bad infection. So the phagocytes are there to consume the guys, but they can also interact with the T cells and the B cells to make sure that you're fighting things off properly. And everything's right there. It's all present there. So the structure goes like this. You have a cortex, which is all of this stuff around here. The cortex is where you have your densely packed follicles. They have the germinal centers with the B cells in there. Each of the germinal centers tends to be surrounded by these other structures that are called dendritic cells. Deeper inside of the cortex, you tend to have a lot of T lymphocytes present to help to fight off infections again. They're very powerful soldiers. With the medulla is basically everything centered here. The medulla has medullary cords, which are thin inward extensions from the cortex. So you tend, again, to have lots of B cells and T cells present. We also have a capsule which surrounds everything. The capsule is shown here. The capsule surrounds every lymph node. It's made of dense fibrous tissue, which is protective and ensures, but it also ensures enclosure. It ensures that everything that's inside of there stays inside of there, which is quite important. If you know anything about lymph nodes, you'll know that they get quite large when you're fighting off an infection, and it's important that that infection does not just burst out and permeate the rest of the interstitial fluid. You want to keep that stuff inside of there. So the role of the capsule is actually quite important. We have trabeculae that extend inward from the capsule and tend to divide the lymph node into parts. You'll notice that there are structures in there that are kind of compartmentalized from each other. And okay, that's what I wanted to say about the structure. So let's talk about the circulation inside of the lymph nodes. That's actually a very important part here. So part of it is the trabeculae that trap fluids as they move through and that kind of keep them circulating through one little area. But another part of this is the idea of the number of vessels. So if we look at the afferent lymphatic vessels, they're listed here. And afferent lymphatic vessels, there's 1, 2, 3, 4, 5 shown here. And what you'll notice is afferent is a word that means at or approaching. And so what we have here are fluids that are entering into the lymph node here, opposite the hilus. This is the hilus right in here, called the hilum. In this picture, hilum or hilus, same thing. So opposite the hilum, so on kind of like the outside edge of the lymph node, you have the afferent vessels. They're bringing the fluid in. They're bringing the lymph in. And what they do is the fluid tends to enter in and it tends to spend quite some time inside of the lymph node, circulating around, coming into contact with all of those special cells that are part of the immune system, and ensuring that if there is any kind of bacterium or virus or pathogen or infection going on, that it's sure to come into contact with a number of different white blood cells. So part of that is that we divide them up into trabeculae so that things kind of swirl around inside one area, which is great. But the other side of it is that the efferent lymphatic vessels over here in the hilum or the hilus are helping to drain the fluid, but they're very small in number. So these are the exit portals here, and they are always fewer in number than the afferent vessels. So in this picture, we show 5 afferent vessels and 2 efferent lymphatic vessels, and I think that that's actually kind of a typical number. So the idea here is that since you have 2 exit portals and 5 entrance portals, that ensures that the lymph is really slowed down as it's passing through the lymph nodes. Slowing down is an important part of filtration. So this is the first time we're seeing that, but we're going to see that theme again, is when we want to filter things, we need to make sure that they're passing slowly.